Hi everyone, my name is Bhavishya. In this lecture, we'll learn something new. So, this is our topology. As you can see, we have completed the basics of RIP and its detailing of RIP version 1. So, we'll keep it concise and short. So, as you can see, this topology here, router 1 is advertising what? It is subnetted, right? But due to the non-symmetry in the configuration of our subnet mask in the interface, it is going to summarize the network, right? So it will advertise here, R1 will advertise R2, 172.16.0.0, right? Now, similarly, in this side, in R3, there is a there is non-symmetry, so it will get summarized and it will receive 172.16.0.0. Same, both are doing. Now, when we see R2, what it will receive, if you look at its table, if you look at the table, so it will advertise the same network, right? And it is advertising via this 30.0, via this fast Ethernet. If you look at here, via this on this fast Ethernet, via this on this fast Ethernet, right? These both are doing. Now, let's suppose PC2 wants to send something to PC1. Okay, now the source IP will be its own IP 40.0.0.2. The destination IP will be 172.16.10.2. The source MAC will be its own MAC. The destination MAC, we are not aware of it, right? For that, we will do the app request to our nearest default gateway. So in our case, it's R2. So it will send a app request to our 40.0.0.1 and it will get the IP address and then it will send the datagram to our R2. Now R2 will go to the IP layer, it will check the destination IP and the destination IP here is 172.16.10.2. But when we look at R2 show IP route command and then we will see what we have. So the only entry we have regards to this is the only network we know is 172.16.0.0 via two networks, right? As we saw here, this via this two paths, this path and this path. Now let's suppose PC2 sent 10 packets, okay, and it knows only two paths. Now here what it will do is, before that, in the entry, when we're talking about this, it doesn't know this. It only knows the major network, that is 172.16.0.0, right? It only knows this. So what it will do, it will load balance it out. What does this mean? So let's suppose what I was saying before. PC2 sent, let's suppose, 10 packets, okay, for our PC1. But due to this condition, and it knows the major network via two paths, it will load balance it out. It will send from this side and from this side too, five packets. So this is how load balancing works. But this is a drawback, and in version 1 it fails because this, if we look at this network, so it is this contiguous network. What does this mean? So it has the same subnets. If you look, it has the same subnets, but it is spread out by two different networks. So that this is a non-contiguous network. So this is how load balancing works. Okay. Now we will see some properties of RIP version 1. So let me pause it here. So the very first property of our RIP version 1 is that it breaks the layer 3 loop. Now what does this mean? Now, if you look at this topology, when we talk about this network, let's suppose R4. Now, to reach R4 for our R1, how much hop count does it needs? If we look at this path, so it's just one hop far, right? Yes. But if we look at this particular way, this particular path, so the hop count is 2, but it will prefer the shortest path, and the best part that we can have is our this path, right? Via this with hop count of 1. Now let's suppose, so here the loop got eliminated, right? We don't have any loop address. So the layer 3 loop that we are having is now break. Now let's suppose this got purged. Let me delete this. So this is deleted. Now the only way, or the way that we have is our this, that is our, we can reach our R4 via this path, having loop, having hop count 2, right? So this was the first property. Now, and similarly, when we talk about the spanning tree, it breaks the layer 2 loop, right? Is applicable for both recursion 1 and recursion 2. Let's suppose we have this topology. Now here R1 is advertising 10.0.0 with a hop count of 1 to R2, right? And now R2 will install it with hop count of 1, but will advertise it with the hop count of 2 to our R3. R3 will install it with the hop count of 2, but will advertise it with hop count of 3 to R4, and so on. R4 will install it with 3 and will advertise it with hop count of 4, and so on. Let's suppose here it has installed it with hop count of 15. Now when it comes to advertising, it will advertise it forward with a hop count of 16, which is not applicable, which is, it will say, the moment it will receive, it will say it's unreachable, right? So we can see 120 slash 10, right? We can see 120 slash 15, right? But we can't see 120 slash 16. So the maximum hop count that we see for RIP is 15 hop count. So this was the second property. Now comes the third one, that